Hi, this is Yuri. In this video, I'm going to speak about commutativity and partial function application. And I will show you why it would be important how we choose the order of the parameters of a function. So let's get started. First in C. I will speak about arrays in C. When we are using arrays in C, we are using continuously allocated memory addresses to store our elements. To jump to a certain element of an array, we must know the element type and the size of the array. Basically, we have to calculate an offset for indexing. This is where the pointer arithmetic helps us. Now we could think of the arithmetic series from math. So, we have an array called A with 3 zero-initialized elements. Try to print the element behind its second index. To do this, we have to calculate an offset where the reference point is the address of the array, which is the address of its beginning element. And we have to dereference this pointer to get the pointed value. This is what we saw here with this syntax. Okay, compile and run it. Sorry, I think it's much easier to follow what is happening if I write this command. Okay, now we know what's happening. Let's express the same thing in a more explicit way. Now we are doing more or less the opposite of the abstraction. So adding a number and dereference it. Right now, I do not want to speak more about the pointer arithmetic. Our goal is something different. So the two things are the same. We know from math that the addition is commutative, and it is true for int values in C also. This is why we could write this. And now we could do the same transformation in reverse. Okay, it works. Let's check it. I think it is a good example of how you could use the concepts you learned from Haskell or from math to discover new expressions or notations in a language. And now, learn more from Haskell. If we have an addition, we could use its commutativity. And we could write the infix operator in a prefix form. This expresses more about the order of its arguments. Okay, right now I try to show or express that we can fix the first parameter. This is what we call as partial function application. If you would like to learn more about currying, please leave me a comment below. We get a new function which requires less parameters. We could name it, of course. For example, the add2 function takes an int and returns an int. Just adds 2 from the right. But be really careful. However, the result is the same. What we want it to do is adding from the left. I do not want to use flip now. To read that, it's usually not the attribute of a beginner. In this form, it is clearly visible. When we eliminate x from both sides, this is what we call as point-free style. But at the first time, I think it is much easier to read in this way. Later, when we trained our eyes, we could use the point-free style to emphasize functions instead of the data on which they are working on. The results of the executions are the same. Maybe we could say that they are semantically equivalent from the user's point of view. However, the way of the calculations are clearly differs. So, with commutativity, we could emphasize something. If we want to draw a line with green color, we could say draw a green line. They could be the same if our operation is symmetric, but could be different. Partial function application breaks the symmetry a bit. This is how the order of the parameters could have an effect of the program design. I think that's it for this video. Just one more thing about fixing parameters. We have a struct, a product type, and the show method, and the data. To set all components of the data, we could use setData. But with this wrapping, we could use it with less parameters also. This is some kind of querying right now without lambdas. Okay, this is the end of this video. I hope you liked it and you will see the next one also. Thank you for your time. Goodbye.